Okay, today we're going to do a lens optical bench lab. We have a projector here, which is the object. If you look here, you can see that we've got a horizontal and a vertical object. The objects on the inside are exactly 4 centimeters, which makes the outside of that circle 4.2 centimeters or 42 millimeters. The inner circle is 2 centimeters or 20 millimeters. So those small little lines are millimeter lines. That's why the objects the white object in the center is 40 millimeters, and then the circle itself is an extra 2. So we've got that on the track, and we have that set at position 0 on the track. And we have our lens set, or pardon me, our screen set at position 100 on the track right here. And we're going to start by moving our lens around the track and getting an image on the screen. And we're going to be able to measure the distance by subtracting from 100. That's the distance to the image. And then, of course, it will show directly the distance to the object. We'll also then move the lens to a different part on the track, and I'm not going to remove it like this, but we'll slide it until we get an image again. So we'll have 2 images for each one of our measurements. And I'm going to turn the light off so that we can get a good view of our images on the screen. Okay, we're going to start with the screen at 100 centimeters, and I'll take the lens and slowly move it back until I get a clear image. And here I have a clear image. So this is very small, and on the camera I know it's just a blurry white dot, but I can actually clearly see the image. You're going to have to take my word for it. And this is a picture of the image that's being projected. Now remember that the image is going to be measured in millimeters on your table when you record it, and the size of the object, remember, is 42 millimeters to the outer ring, and that's what we see right here is the outer ring. So the object height is 42 millimeters. This is the image height in millimeters. Also remember that the image height, you'll have to take my word for it again, this is upside down. It's very small and you can't see it, but it's upside down. So the image height will have to be negative when you enter that in your table. Right here, you can see this is the distance from the object to the lens. And if you subtract this from 100, you'll have the distance from the lens to the image. So this will be the image distance subtracted once you subtract from 100. And this is, we can read the object distance directly. And now we're going to move closer to the image, or to the object, until we get another image. And there we go. Starting to see a little something. And there. Okay, now we've got a pretty clear image. As you can see, this is the inside ring. The outside ring is actually up here. So the object is, or the image is very big here. But, so this is the inside ring. And if we wanted to, we could measure that. Remember, each one of these little marks is a millimeter on the object, but it's now much bigger here on the image. Okay, so let's go on and measure this height. And if we go from line to line, remember that the object is 20 centimeters and, 20 millimeters, 2 centimeters. And here, this is 16 centimeters, so this is 160 millimeters from top to bottom. Also remember that the image height, it should be a negative because this image is inverted. And you can't really tell that very easily, but if I hold my hand here, you can see the circle, which is at the bottom of the object. So this object is inverted. So you can subtract from 100 this number to get your image distance, and this is directly the object distance since our object is at 0. And now we're going to move into 90 centimeters, and we're going to repeat the process. So we come out until we get a clear view. We no longer need to measure the object height, but we do need to take a look at the distance. So this is the image distance. When we subtract from 90, we get the image distance, and this is also the object distance directly. Now we'll move in to get a second image as we get closer to the object, right here. Okay. So if we subtract from 90, this is our distance to the image, and it's our object distance directly. Let's repeat the process at 80 centimeters. We'll move out until we get a clear view. It's much easier to see because it's getting a little bit bigger each time. So we've got a clear shot here. So this is the distance subtracted from 80. Or if we have 80 minus this, we've got our image distance, and this is our object distance directly. Now we move in closer to our object to get another image, right? Let's try and get it in as good a focus as I can. There we go. So this is our object distance directly, and if we subtract from 80, it's our image distance. Now we'll repeat again, move into 70 centimeters, and move back until we get a clear image. There we go. So 70 minus this will give us our image distance, and this is also our object distance. Move back and get that in focus. There we go. So 70 minus this number is our image distance, and this number is our object distance. Repeat this again at 60. Now, here we go. All right, so this number, our object distance directly, and if we subtract from 60, it's our image distance. I know I keep flipping those around to keep you on your toes. So let's move this in until we get another image. There, that looks good. All right, so this number, our object distance, and if we subtract it from 60, it's our image distance. And we'll do one more trial. We'll move into 50 centimeters. I'm going to have to set my chair up so that I can see. We'll move back. And there we go. That's quite a clear image. So this is our object distance. And if we subtract from 50, it's our image distance. And one more image we can get. There, we got the whole thing on our screen at the same time. This right here is our object distance, and if we subtract from 50, we've got our image distance. So now you have all the data that you need to perform your calculations, so go ahead and get started.